Alright, welcome back. So today we're going to be looking at monic quadratics. And we're going to factor them. So we're going to look at factoring monic quadratics. So I'll bring up a question and we can have a look at them. So we have x squared plus 8x plus 15. And the quadratic just refers to the highest power of the polynomial, right? And what we need to do to factor these three-term expressions is essentially follow a few key steps. We need to find values which sum to this coefficient here, but whose product, if we multiply them, also work out to be 15. So the easiest way to do this for me is to start out with the product here. And we're thinking about factors that produce 15. So 3 times 5 or 15 times 1. But then you're thinking which of those would end up adding up to be 8. And then 3 plus 5 would be our choices. So 2 sets of numbers that sum or add together to give 8 and whose product is 15 are going to be positive 3 and 5. Once we have found that out, we can then rewrite the entire expression as x squared plus 5x plus 3x plus 15. It's important to remember it doesn't matter if you have the 5 first or the 3 first. As long as you've identified the correct ones, it won't matter. The math will still be the same. We've written out the exact same expression, just slightly differently. Now we have 4 terms instead of 3. The 8x has been broken up into 5 and 3. 5 plus 3 is still 5x plus 3x is still 8. So nothing has changed. These are still equal. Right, now we're going to start removing or factoring by groups, okay? So what we do is we might see, well, what's a common factor between x squared and 5x? Well, the x is a common factor. So I'll take out the x and I'll be left with x plus 5. Right, I've still done the exact same thing. If I do x times x, it's x squared. If I do x times 5, it's going to be 5x. So these two groups of 2 terms and this little expression here are both equal. Now we're going to do the exact same thing with this group over here. All right, we're going to look, what's a common factor between 15 and 3? Well, 3 is a common factor. So let's take out the 3, and then 3x divided by 3 is just x, and then 15 divided by 3 is just 5. And we're left with x times x plus 5 plus 3 times x plus 5. And if you remember from our early expansion videos, we can rewrite this as x plus 3 times x plus 5. So it becomes the product of 2 binomials. And we have essentially factorized this form. If you multiply this whole thing out, you will get back to where we started. So this is our factored form in the end. It is kind of complicated, but once you get used to it, you start to see the patterns. It can be very complex, and often there are some very annoying questions that use this technique, but we'll get into an easier way to solve those later. All right, let's try another one. So, if we look at our next one, we have x squared, and we have also gotten 5x plus 6. So one thing we want to do when we're looking at these is we do want to consider the signs. So it's not always going to be all pluses. So x squared minus 5x plus 6. That means we're trying to find values which sum or add together to -5, but multiplied together, their product is 6. So you have to think about starting out with, okay, well, what are the factors of 6? You know, I can do 3 times 2, or I can do 1 times 6. And then once you've chosen those, you have to say, well, hang on a second, what two values will add together to give a negative value, but when I multiply them together will give a positive value? And the only two signs that are going to be able to do that is if they're both negative values. So if we multiply two negatives, we'll get a 6, a positive. But if we sum two negatives, we'll get a negative. So this tells me that we're actually looking for two negative values, and then they're informed by whether they are, what product of 6 they have. So that means that we were going to have either -1 times -6. And if we add those both up, so let's do the sum first. -1 plus -6 is -7. So it can't be those two. What about -2 plus -3? Well, that's going to be -5. What about -2 times -3? Well, that's going to be +6. So the two values we're looking for are -2 and -3. We've solved for our two values. Now we just need to rewrite the entire expression. So x squared minus 2x minus 3x plus 6. Still exactly the same. These two terms at the bottom still equal 5x. There's still this -5x. So it's still exactly the same expression. All right. Now we just need to factor by grouping. What do these two have in common? Well, these two have the common factor only of x. So let's factor out the x. X divided by x becomes x. Minus 2x divided by x becomes -2. All right. Now, this is where we can get into some trouble. If we are going to factor out the -3, we need to change the signs because we'll be dividing by -3. So the common factor between these two is 3, and you can factor out a +3, or you can factor out the -3 and you will get the same result. So if I factor out -3, okay, -3x divided by -3 is just x. But 6 divided by -3 is -2. All right, so we can't just write this perfectly as we had before. If you don't take care of the signs, you will have an error. And most of the times the errors come in where we don't apply the same treatment. So the end result is going to be x minus 2 times x minus 3. You can write that either way because it's multiplication. All right, so that's our factored form of the first expression. Let's try another one. Okay, x squared plus 2x minus 15. So we're looking for two numbers that sum to 2, but when we multiply them, they get -15. Now, how are we going to get a negative result for multiplication? If we have two of the same sign, either positive or negative signs multiplied, they become a positive number. So this can only happen if one of our values is positive and the other one is negative. Now let's think about our potential factors of 15. We have 1 times 15, which isn't going to work. And we have 3 times 5. That's pretty good. Now we need to decide which sign is going to be which. Because we end up summing resulting in a positive number, that means the positive value will have to be larger than the negative value. So if we did 5 as the positive plus 5x plus or minus 3x, we would get positive 2x. You don't have to write the positive. And if we multiplied 5x by minus 3x, we would get our minus 15 or minus 15x. Now, the result here tells us that our two numbers we're looking for are 5 and minus 3. Once that's solved, all we got to do is rewrite the entire expression. x squared plus 5x minus 3x minus 15. Still exactly the same expression. Now factor by grouping. So these two have in common only the x. So we factor out the x, we get x plus 5. These two, they have a common factor of minus 3. So we can factor out the minus 3. And then negative 3x divided by negative 3 is just x. And 15, minus 15 divided by minus 3. A negative divided by negative will just be positive. So you can do 15 divided by 3, which is just 5. Okay, now because they're both being multiplied by essentially the same binomial, we can rewrite this as x minus 3 times x plus 5. And just if I wasn't clear, this is exactly the same as x plus 5 times x minus 3. Those two are equivalent. Alright, let's do another one. So we have a squared minus a minus 20. So hidden here is negative 1. Okay, there's always the coefficient of 1 in front of just a single or lone pronumeral. So we can imagine the coefficient here is negative 1. So we have to sum must equal minus 1. And the product has to equal negative 20. Right, so let's start thinking about what our factors of 20 are. Well, 20 times 1 probably won't work. 4 times 5 sounds pretty good to me. Now we need to decide where our signs are going to go. In order for this to be negative at the end, we have to have a positive value and a negative value. This is informed by this value here. If we need our middle term, the coefficient to be negative, that means that the larger value has to be negative and the smaller value has to be positive. So we can do 4 plus our minus 5. Well, that will equal negative 1. And 4 times negative 5, well, that will equal minus 20. So those are the perfect two values. So we'll take 4 and minus 5. Now let's just rewrite the entire expression. A squared plus 4a minus 5a minus 20. Keep note, there is a quicker way to do this, and it just has to do with using these two values, but this method will become very useful later when we're doing non-monic quadratics. Okay, so factoring by grouping, we can take out the a from the first one, go a plus 4, and for these two we can factor out minus 5. So minus 5 gives us a plus 4 again. Left over with a minus 5 times a plus 4. Okay, and that's what you're left with every single time. You have to end up in a situation where both of these values out the front, these coefficients, are being multiplied into this binomial that is exactly the same in order for us to end up with this. Okay, now let's go on to our last one. We have x squared minus 11xy plus 24y squared. Okay, it looks kind of complicated, but remember, we're trying to find values that are going to sum to the middle and that are going to multiply into the last one. So we need to just think about the coefficients. Okay, so let's get started. We need to think what's going to sum to minus 11 and what is going to be the product of 24. Well, what are the products of 24? Well, we can say 24 times 1. We can also say 3 times 8. 3 and 8 looks pretty good to me. So we would probably need them both to be negative in order for the sum to be negative 11 and the product to be positive. So we're going to use negative 3 and negative 8. And we can look at that. -3 plus -8. If we sum the both together, we'll get -11. And -3 multiplied by -8, well, that's just going to be +24. So this is our pair that we're looking for. Okay, let's rewrite this entire expression. So we've got x squared minus 3xy minus 8xy plus 24y squared. All right, so factoring by grouping, let's take out the x, and we get x minus 3y. And factoring by grouping, let's take out the minus 8y from this one here. So minus 8y, well, that will leave us with just x. And then 24 divided by -8 is -3, and y squared divided by y leaves us with y, and the end result is x minus 8y times x minus 3y. And that's our answer. This one was a little bit tricky, and I actually regret including it, but if you got this answer, you try it yourself, that's great. So that's it for this video. Hopefully it was helpful, and I will see you in the next one.